Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrell's Algebra 2 class. Today we are moving on to a new skill. We're going to be dealing with radicals in this chapter, radical expressions, radical equations, radical graphs. So it's a lot to do, but it's very simple. And it's going to be simple because we're going to learn step by step. And the first thing we're going to talk about today are square roots. Now, I'm sure you've worked with square roots before. Today, we're really going to knock out any preconceived erroneous information, and we're going to hopefully make you masters of square roots. Now, today, we're going to learn how to simplify square roots, but before we do that, let's just go back in time a little bit. If you remember, 5 squared means 5 times 5. Remember that the exponent tells you how many times to multiply the base by itself. We've talked about this, right? Okay, so 5 squared is 25. Square roots are exactly the opposite of raising a number to the second power. So if 5 squared is 25, 5 is a square root of 25. 6 squared is 36. So that means 6 is a square root of 36. 12 squared is 144. So that means 12 is a square root of 144. Notice though how I tell you it's just a square root. There are 2 square roots. Okay, there's a positive and a negative. And let's explain this. But does everyone understand so far? 6 squared is 36, so 6 is a square root of 36. Square root is the opposite. It reverses raising a number to the second power. Sorry. So square roots have 2 real roots, my friends. They have a positive root and a negative root. The positive root, sometimes called the principal square root, okay? We're going to be dealing with other radicals throughout the chapter. So if let's say it's a third root, okay, where the index is 3, and we'll talk about that in a second, it could also be called the principal nth root. It's called the principal root because most times when people say, give me the square root of whatever, 16, it's 4. Why? Because there's nothing here in front. It's a positive. It's an implied positive. If I were to say to you, give me the negative square root of 16, then they're asking for the negative root of that number, okay? So that's why you have 2 roots. You have a positive root and a negative root. The positive root, again, is called the principal square root. The negative root is its opposite, okay? So you always have a positive and a negative. Now, why do you have a positive and a negative square root, you might ask? Well, if I take 5 and I square it, it's 25. But if I take negative 5 and I square it, isn't it also 25? So the real square root of 25 is positive 5 or negative 5. Why? Because 5 times 5 is 25. Negative 5 times negative 5 is 25. But notice how the inside is positive. Is that kind of like refreshing your memory a little bit, guys? This should be pretty simple so far, right? Okay, now, everyone has worked with radicals. Yeah, I know. However, not everyone really understands or knows the nuances of radicals, okay? There's a lot of vocabulary here that you should learn. First of all, this little guy right here, it's going to be a number in between this little hook here of the radical. Okay, that is the index is what it's called. When you just have a square root like that, the index is invisible. That implies that there's a 2. Okay, so you're never going to see a square root with a 2 there, ever. It's going to be blank. But that blank radical implies that it's a 2, that it's a square root. What is this 2 all about? Remember how I just said that a square root, it's a number times itself, correct? So for example, if I have the square root of 25, doesn't that break up into 5 and 5? Don't I have 2 5s? Every set of 2 comes out as 1. Okay, sorry about that. So since I have 2 5s, okay, the way radicals work, you look at the index and you say, okay, how many values do I need to pull one value out? Well, in a square root, I'm looking for sets of 2. So every 2 values comes out as 1. So I have a 5 and a 5, so it comes out as a 5. So this index lets you know, hey, reader, this is how many sets of a particular number or variable I need to pull 1 out. Are you guys with me? Okay, so that's the index. And yes, someone had asked, what if the index is 3? Okay, check this out real quick. This is not our lesson today, but just so you could understand. I could break up 8 into 4 times 2. I could break 4 into 2 times 2. Remember, I briefly just said that the index tells you how many you need of one number or one variable to pull one whole value out. So don't I have 1, 2, 3 2's? So the cube root of 8 is 2. Why? Because I took 3 2's to pull out one value of 2. Does that make sense? Promise? Okay, so that's what the index does. It tells you, hey reader, this is how many you need of one number or variable to pull it out of the radical. You with me? Okay. The inside number, that's called the radicand. No big deal. It's just called the radicand. Know your vocabulary. A lot of times in word problems, they're very simple, except people don't know what index it are. Or they don't know what the radicand is, and then they're all messed up. And last but not least, this beautiful little sign here, that's called the radical sign. You can't call it a square root unless it's like this. That's a square root. That's a cube root. That's a 4th root. That's a 5th root. I changed the name by the index, okay? But the symbol itself is called a radical sign. So you can't just look at any radical and say, oh, that's a square root. No, it depends. It is a radical. If there's no index, it's a square root radical. If there's a 3, it's a cube root radical, etc., etc. Does that make sense, my friends? Yeah? Okay. Okay. Again, just a reminder, very important. If there is no index, then it is a square root. The index equals 2 when it's blank, okay? So please, when I give you that, that is implying a 2 here. 4 times 4, 2 4's come out as 1 4. The index tells you how many values you need to pull out one full number or variable from the radical. You guys with me? Okay. Now, some square root properties that are really important and easy. Every positive real number has 2 square roots. One positive, one negative. If I have the square root of whatever, 144, that really equals plus or minus 12. Because 12 times 12 is 144. Negative 12 times negative 12 is 144. The positive square root of 0 is 0. There is no plus or minus for 0. It's just 0. And for any real number, a, where a is greater than 0, the square root of a squared equals a. Why? Didn't I tell you that the square root is the opposite of squaring something? So if I square a square root, the square root symbol goes bye-bye. And you're only left with the inside value. So for example, the square root of 16 squared, it's not 4. That cancels, it's 16. The square root of 7.5 squared, that cancels, it's 7.5. So if I want to get rid of going down the line, later down the line, we've talked about this already. If I have a square root of x equals 5, I can square both sides, cancel the square root, x equals 25. You feel me? Yes, sir. We're going to talk about that in a second. The question was, what about if a number is less than 0? What if it's negative? That's not a real number. We'll talk about that literally in like 2 slides. Sir?
Why does it equal 25 and not 5?
Okay. Why does it equal 25 and not 5? Let's talk about this. Thank you, sir. I had the square root of x equals 5. 5 square one side, I got to square both sides. I may have made a mistake, and that's 25. If I made a mistake, I apologize. Thank you, sir. Does that make sense, boys? Okay, and move on. Okay, now, simplifying square root radicals is very easy if you know your perfect squares. At this point, I'm hoping that your multiplication skills are very strong and solid. We haven't used a calculator all year because of this. I want you to be strong. Remember that a perfect square is a product that came from multiplying a number or variable times itself. Okay, it's just a recurring theme. Square root of 25 is 5. Why? Because 5 times 5, or 5 squared, is 25. I can pull out from this 25 2 5s. Since I have a square root, every set of 2 numbers or variables, a 5 and a 5, comes out as 1 5. You guys are with me, right? You should have these first 15 perfect squares committed to memory. It's just going to help you so incredibly much. I can't even tell you. It's going to help you so much, especially when we're simplifying larger radicals, okay? Just really quickly, we'll go through it. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. Square root of 196 is 14. And square root of 225 is 15. These are usually the bases that they use. Can they go higher? Yes. But at least you know you have a base. For example, if they tell you the square root of 289, you know it's got to be higher than 15, right? So then you can start testing. Okay? So this is very, very important. Recognize perfect squares makes simplifying square roots actually easy and fun. It's kind of like a puzzle. Okay? So you got to memorize these first 15 perfect squares. Strong suggestion. Now, let's get to this. In order to evaluate a square root, simply ask yourself, what number times itself equals the radicand? You're looking for square roots. So, simple. Square root of 49 equals 7. Square root of 144? 1.44? 1.2. Now, square root of 4 over 36. When you have a fraction inside of a square root, you are allowed to break that up into the square root of 4 over the square root of 36, which then would become, what's the square root of 4? 2. What's the square root of 36? Which then would reduce to 1/3. Very good. The square root of 4.3 squared. That's right. When you raise a square root to a power of 2, the square root and the power of 2 cancel, and I'm left with 4.3. Negative 5 times the square root of 81. Okay. You cannot multiply whole values or integer values into a square root. So you cannot do this. Oh, that's the square root of negative 405. No, 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 no. No, 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 no. You can only multiply radicals to radicals, and we'll get into that in a couple sections. But I need you to be confident. You cannot multiply integers into a radical. You cannot. So what do? This is negative 5 times the square root of 81, which is 9, which is negative 45. Done. Sir.
For the slide before, I noticed the pattern that, like, if you ever have to go above 15, like,
Yes, sir.
yeah, I've known it, but like, I just got reminded of it. Like, 5 and it keeps on going up every odd.
Oh, okay. He said there was a pattern for the square roots. Awesome. Investigate the pattern. Or just memorize the square roots.
No, like when it goes to 16, you're going to be like, what? And then
Okay. Or if it goes to 16, you could do 16 times 16 and see if if that works as well. But yes, that's a good pattern. God bless you. That's great. Okay. Square root of 4. Okay. Square root of 4 plus square root of 64. The temptation is to say, oh, this is square root of 68. No. Radicals work like variables. You can only add like radicals. So if I had 5 square root of 2 plus 6 square roots of 2, then I'll have 11 square roots of 2. I can do that. 5 square roots of 2 plus 6 square roots of 2, that's 11 square roots of 2. I can do that. And again, we'll get into that later. I just don't want you to get confused now. You cannot add these together unless the insides are completely the same. So in this case, simplify each. Square root of 4 is plus square root of 6 is, so that is 10. Done. Square root of 9 plus 16. It's inside of the radical. So you can add these. This is going to be a square root of 25, which equals 5. Now, square root of 64 minus 4 times 7 times 1. Please remember the order of operations. This is square root of 64 minus 28, which would be 36, right? Square root of 36, which equals 6. Please do not do square root of 64, then square root of 4, and then subtract them, because it's not gonna work. And then multiply by 7. No, it's gonna be a disaster. Please go ahead and perform as if that was inside of a parenthesis. First, complete everything, and then, once you have one value, take the square root. Yes, sir. Okay, thank you very much. The question is, would G be 5 and negative 5? That's a wonderful question. If I'm just telling you to evaluate it, and they have nothing in front of the radical, they're looking for the principal square root or the positive square root. If I tell you negative square root of 25, that's going to be negative 5 because they're looking for the negative root. If I tell you plus or minus square root of 25, that's going to be 5 and negative 5 because you're looking for both roots. When you're solving an equation, though, if I have square root of x, let's say I have x squared equals whatever, 5, okay? If I take the square root of both sides, then I have to have plus or minus square root of 5. You feel me? Promise? Thank you, sir. That answers your question, my man? Thank you, brother. Okay, now, how do you determine if a square root is rational, irrational, or not a real number? Pretty simple. Perfect squares are rational. Rational square roots equal perfect squares. So like the square root of 9, or the square root of 144, or the square root of 225, or the square root of 4, or the square root of 16, or the square root of 1. Okay? All of those are perfect squares. Perfect squares are rational. Period. 2. Irrational squares, or square roots. Irrational square roots are non-perfect squares. Period. That's it. Square root of 30 is irrational. There is an answer for it, I promise you. But it's a decimal answer. And when you get a decimal answer from a square root, it is not rational. It is irrational. So be careful. A lot of times people think if it's even, it's going to be rational. No, it has nothing to do with even or odd. That's why I gave you an odd perfect square and an even perfect square. It does not matter. If it's not perfect, it is irrational. And the square root of 30 is not a perfect square. Square root of 42 is not a perfect square, so those are irrational. And last but not least, the square root of a negative real number is not a real number. And I will explain why. Let's take this negative 4. My friends, what times what? Well, what times itself is negative 4? Nothing. A lot of times people say, oh, negative 2. No. 2 times 2 is 4. Negative 2 times negative 2 is 4. So no number or variable on this universe multiplied by itself will ever give you a negative. So if you have the square root of negative 4 at this point, that is not a real number. Now, just so you know what's coming up, this is what's called an imaginary number. Square root of negative 4 would really be 2i, where I is the square root of negative 1. Okay? We have not gone into that, right? Because my classes are getting jumbled in my head. This is coming soon. But that is not a real number. That is called an imaginary number. It's coming up soon, though. You guys with me so far? Okay. Now, when the radicand is not perfect, you can write a decimal approximation of the radical. You can simplify the radical using properties of radicals. We haven't done any of those properties yet, so that's coming soon. Or you could use a calculator to find the decimal value. I will let you use a calculator to find the decimal value just for speed. However, what if you get a teacher or a college professor that doesn't allow calculators? Let me show you how this works. Find the square root of 17. Okay. Put square root of 17 in the middle. What is the closest square root less than that that's perfect? Square root of 16. What is the nearest square root larger than that that is perfect? 25. Okay. Square root of 16 is? Square root of 25 is? So you know this number is between 4 and 5, right? Now look at the value. Is that closer to the square root of 16 or closer to the square root of 25? So let's start with decimal values closer to 4. So I'm going to start with 4.1 times 4.1. 1, 4, 4, 16. That's 1681. Let's try 4.2. Let's see who's closer. 4, 8, 8, 16. 4, 1, 6, 1, 7. Okay, who's closer? 16.81 or 17.64? So this is roughly, approximately 4.1. Okay? Now, somebody put that in your calculator. Please. What are you going to get? What is it? 4.123, yeah. So 4.1 is a pretty darn good estimate, isn't it? Nice, you see that? You with me there? So now you know how the calculator gets it. Now, how come the calculator went further? We could have gone further too. If I would have gone 4.12 and then 4.12, that would have brought me that much more closer. But I'm not going to get into that. In the real world, people would use a calculator. I just want you to understand what the calculator is doing. Is that fair enough? Thank you. Now, determine whether each of the following is rational, irrational, or not a real number. Square root of 70. It's irrational because it's not a perfect square. Square root of negative 100. Not a real number. Very good. No. The question was, is there a sign for that? And the answer is no. Square root of 225. Rational. Because it's 15. Yeah, it's perfect square. That's simple. Make sense? All right. Now, sometimes you have to simplify variables in a square root, or in any radical for that matter, which is very easy. I think the variables are easier than the numbers. All you have to do, please pay attention, all you have to do is divide the exponent of the variable by the index of the given radical. Multiply the exponent of the variable inside the radicand, okay, the radicand. Go ahead and divide that by the index of the radical, which in the case of a square root is, of course, 2. The whole number comes out of the square as the exponent of the variable, and all remainders stay inside the square root as the exponent of the radicand variable. I'm going to explain this more. Hold on. Give me a second. Please be aware of the following, though. Remember how we just said we cannot have negative values inside of a square root, correct? So that means that whenever I am simplifying variables, if I pull out a variable that has an odd exponent, it has to come out in an absolute value. Since square roots cannot have negative radicands, all real numbers and odd exponent variables or polynomials must come out as an absolute value. Let me explain this nonsense. Let's say I tell you, find the square root of just straight up x to the 10th. Okay. What's the exponent of the variable of the radicand? 10. What is the index? What's 10 divided by 2? Are there any leftovers? So it comes out as x to the 5th. But is that an odd exponent? So it must come out an absolute value. Because if it's an odd exponent, that can be negative. And you are not allowed negative variables or numbers inside of a radical, inside of a square root. So if you pull out an odd variable or an odd powered polynomial, it must come out an absolute value. Now, let me show you one where there's a remainder. Let's say I tell you, give me the square root of x to the 17th. Okay? 17 is going to be divided by the index. What's 17 divided by 2? How many times is it going evenly? 8 times, right? And what's left over? Boom. Why did I not put that x to the 8th in absolute value? Because the exponent is even. Very good. Does that make sense? A little bit more now? Okay, now, let's look at some examples. Okay, what's the square root of 15 squared? Okay, be careful. It's really the absolute value of 15. Why? Because what's the power of 15? What's the exponent there? 1. So it equals 15. Be careful. Exodus, yes, sir.
Would that equal plus or minus 15?
No, would not equal plus or minus 15. No. Just be, the absolute value of a number is never plus or minus. Okay, remember, we use plus or minus when we're solving radical equations. Square root of x to the 7th. Okay, 2 goes into 7, how many perfect times? 3. But that's odd, so I gotta put an absolute value. And what's left over? 1x. Boom. Square root of x to the 8th. How many times does 2 go into 8? Do I need to put that in absolute value? No. Okay. Square root of 3x minus 1 squared. That cancels with that. But this is a polynomial, correct? And that's a polynomial to the first power, correct? So it must come out in absolute value. You guys with me? Huh? Can I repeat that? Of course. Square root of 3x minus 1 squared. This power of 2 gets canceled out with that square root. So I'm left with 3x minus 1. But isn't there an invisible power of 1 here? So therefore, this must be an absolute value. Square root of negative 15 squared. Here's the danger. This cancels. People go negative 15. Is that possible? That's why we put it in absolute value, because it's to the first power. So this will equal 15. Now, square root of x squared plus 6x plus 9. That's we're going to have to factor. And in fact, that's a perfect square. That's x plus 3 squared. So the square root cancels out the power of 2. So this comes out as x plus 3. But what is the power of that polynomial? So this has to come out in absolute value. Does that make sense, my friends? Awesome. Thank you very much. I hope you learned a lot, and have a great day.